Hey everybody, welcome to video 2-3. We're going to be working with rotations on a coordinate plane in this video. And you've already watched the textbook video, the really quick one there with one of our textbook authors whose name is Dr. Berger. And he showed you kind of how he takes his whole entire coordinate plane and turns it. And that's what I do too, guys. So that's the strategy that I would give you for these problems, is to take your, whether it be your book or worksheet or even your quiz or test if you have a problem like this, and actually turn it. So if you're viewing this video right now either on a smartphone or on, let's say, a tablet, or even if you have a laptop that you can kind of pick up and rotate, I would really do that. If it's a smartphone or a tablet, make sure the orientation is locked so that as you turn it, the screen doesn't normalize back to what it should be. We want it to actually go sideways, kind of thing. So that's what I'm going to do here with example 2, but let's talk through here. Just as before with reflections and translations, there are some rules for rotating around the origin on a coordinate plane. A couple of things I want to highlight here. The only rules that exist on the coordinate plane are if you have multiples of 90 degrees as far as your rotation goes, because of course that's one whole quadrant at a time, okay? The other things you need to take note of is when no direction is specified, you can assume that a rotation is counterclockwise. And if you ever get confused about that, you can either look at a clock or know that the default direction is the exact order that that each quadrant is numbered in. So if you know that the quadrants, go quadrant 1, 2, 3, 4, that is the order of a counterclockwise rotation. The other thing that's important to know is if you go a certain number of degrees counterclockwise, you can land in the same spot by rotating clockwise the rest of that circle. So let's say you rotate 90 degrees counterclockwise, that would be the same as 270 degrees rotation clockwise, okay? So in example 2, we are going to be rotating this quadrilateral ABCD on the figure 270 degrees, and again it's not specified, so we can assume that's a counterclockwise or a normal direction of rotation. What I want to do here is to basically make a list of your new points after you turn your paper and list the image points as you see them. And remember, after you turn it, you kind of have to ignore the labels of X and Y axes and pretend that it is as you're looking at it straight on at that point after it's turned, okay? So here we go. We are going to rotate 270 degrees counterclockwise. Now that's the same thing as above here. That would be the same thing as just moving it 90 degrees clockwise. So that's what I'm going to do as far as turning my tablet. I'm going to turn it clockwise or to the right, just a 90-degree turn, okay? So I'm going to do that right now, and then you're going to see me writing sideways if you haven't turned your thing. If you've turned it, you're going to see me writing the correct way. So I'm going to make a list: A prime, B prime, C prime, and D prime. And now I am going to look at my axes as if this right here is my new x-axis and this is my new y-axis. So the points that I'm going to specify, I'm going to zoom in a little bit, are going to be, counting to A would be 2 over and none up, so that is going to be the point 2, 0. B prime is going to be counting 1, 2, 3, 4 over and down 1. So that, of course, is the point 4, negative 1. C prime is counting 2 over and down 4, so that's the point to negative 4, and then D prime is counting 1 over and down 3, so positive 1, negative 3. Okay, so those are my points, and now I'm going to turn my grid back, and I'm going to zoom back in here, or zoom back out so we can see everything. And you can see that as we listed it sideways, so we should be back to looking at the screen normal now, we can see that counting on the grid, these points that we came up with without looking at the answer are exactly the same as what you would get if you use the formula. So I wouldn't necessarily, you guys, go about memorizing these formulas, because I'm not going to ask you to do on the coordinate plane any kind of rotation that is not one of these multiples of 90 degrees where you can just turn your paper, okay? So that's what you want to do, just turn your paper and list the image points, and then of course go ahead and plot your points when you're done. Okay? Let's do another one so you can kind of see the idea again. I'm on page 91 here, and we are going to, for part B, look at a triangle, and this time we are rotating it 180 degrees, as you can see here. Now, because 180 is half the circle, it actually doesn't matter whether you go counterclockwise or clockwise, you're still going to land in the exact same spot, but that's 2 turns of my screen, so I'm literally going to be turning it upside down, okay? If we look at the rule, we can look at the translation rule that 180 degree rotation takes my x, y, and just puts a negative in front of each one, or changes the sign of each of those coordinates. But let's just have fun with it and actually turn our tablet or smartphone or our laptop even upside down. Be careful so you don't smash the screen or the keyboard when you do this. It can be a little challenging, but bear with me. So I'm going to turn it right now. And so again, if you have not turned your device, you're going to see my writing come out upside down, but it'll make perfect sense if you're looking at it the way I am, which is upside down right now. Again, this is now becoming that this is your x-axis and your y-axis after we've turned it 2 quadrants, so it's upside down. But this time, instead of my positive x being over here like it is normally, my positive x is on this side, my positive y is here, my negative y, and so on, okay? So we'll zoom in a little bit, and I'm going to make a list of my points. Okay, so we have gone, we need to make a list of our points KLM, so we're going to have K prime, L prime, and M prime. And as we count the coordinates, K prime is now 2 left and 1 up, so K prime is negative 2, 1. L prime, if we count, is now 4 to the left and 1 up, so negative 4, 1. And M prime is only 1 to the left and 4 up, so that is the point negative 1, positive 4. Okay, we've written down our points. Now we're going to turn our paper back to normal. So I'm doing that right now, and we'll zoom back out, and we're going to compare these points right here to what we would get if we used this rule, change the x coordinate and the y coordinates sign only. Okay, so 2, negative 1, of course, is going to become negative 2, positive 1, and look at that, there's negative 2, 1 for our K prime. Using the rule, 4, negative 1, changing both signs is negative 4, positive 1, and again, that's where we landed. And you can see the same thing happening with M prime. It's negative 1 and positive 4. So as we go ahead and plot that, don't forget to plot it. Our triangle is going to land, I'm just going to sketch it really quickly. It's just up here in the second quadrant to answer the question there. We started in the fourth quadrant and we're landing in quadrant 2. Alright, so that's how you guys are going to do rotations on the coordinate plane. I hope you've had some fun kind of flipping things around. We're going to do all the rest of the rotations from this section together because, like the outline says, they require the use of a protractor, and it's best demonstrated in person. So as we move on to the very last page here, I would like you to do these rotations of 90 degrees for number 7, and that is, of course, counterclockwise, and 270 degrees for number 8. Make sure you do your turn 7 and 8 and attempt those before we get back together. Alright, that brings us to the end of our rotations in the video portion of lesson 2-3, and we'll do the rest of the rotation information in class because it's really better demonstrated, as I said, on the outline in person and with a protractor. So we'll work on those together next time.